Integral of e raised to power minus y sine y y. Does it make sense?
Yeah.
Can we move on?
No. Come back. Then why? I don't get that. I don't get that.
Do you understand what we did up to this point? Okay, so look at something now. What if we actually interchange? If we had used the v to be equal to e raised to power minus y dy, and we took u to be equal to cos y, what do you think would have happened? So let's try that out. Maybe to be simpler than this. So if we took our u to be equal to cos y and v to be equal to e raised to power minus y, what will happen? We're going to have our u, the x, u to be equal to, this will be minus sine y, and then you are going to have v to be equal to the integral of this. What would that be? Minus e raised to power y. Do you understand that? Okay. This will give you the same results. Is that clear? By the time you make substitution. So what you can do again is that you work on this portion. Okay? Using when you work on this, now using the same product rule, it will return to cos. Do you understand me? Then when it returns to cos, it's going to be the same as what you have on the other side. Then you can collect like terms. Do you understand what I just said? Do you get what I just said? When you break this down now, it will return to cos. Y something, then we'll now put it back and then we can separate the variables. So we'll put them together. So let's deal with this now. So we're going to have for this integral of e raised to power minus y sine y dy, we can say that let u equal to e raised to power minus y and the v equal to sine y dy. So to follow that du dy equal to minus e raised to power minus y, and this v is going to be equal to minus cos y. Does it make sense? Do you understand that? When you integrate this, you're going to get this. So at the end of the day, when you use that formula, we're going to have integral of e raised to power minus y sine y dy to be equal to uv. So uv, that is u here, e raised to power minus y, multiplied by v, that's minus cos y, minus integral of v du. So that will be equal to integral of minus cos y, multiplied by, what's the next one? du. Du is going to be minus e raised to power minus y y. Does it make sense? This is going to be equal to minus e raised to power minus y plus y, and then minus e raised to power, the minus here will count to this minus, e raised to power minus y plus y y. Is that clear? So I can now put this into this. So instead of having this one here. So when we do that, can I wipe this off? Wait. Don't get tired. Don't give up. Sorry, you can give up. It's not true. You have tried. You give it up already. Yes. You have done 2 tests. Yes. You can give up. You have not gone too far. You only had 1 level.
Like level 1.
Now we move on. So what we want to do now, listen. We're going to put in these results here. Are we together? So we do know that we want to get, please pay attention now, the figure of e raised to power minus y plus y to y. We found it to be e raised to power minus y sine y, then plus this derivative. So we have found this derivative now to be equal to this. All together. So instead of putting that in, I'm going to put that result there. That's minus e raised to power minus y plus y, then minus the integral of e raised to power minus y plus y to y. Does it make sense? You can now move this to this side. Does it make sense? They are the same. I can move them together. That will give me 2 integral of e raised to power minus y plus y dy because e raised to power minus y, I mean sine y minus e raised to power minus y plus y. So at the end of the day, I will have my integral of e raised to power minus y plus y dy equal to 1 over 2, abi? I have to divide both sides by 2. So that will be e raised to power minus y all over 2 into sine y minus plus y. That is that about that. You get it?
That's not very
Come on.
That's what we got before. You know how we came about this, right? Then we needed to find this. So we found this to be this.
using the product
So that means that instead of putting this here, I can put that result. That's what we have here. This result, that is it here, plus this. This one has been solved here. Do you understand that? So you just substitute that, then you collect 9 lengths.
Yeah, that's fine.
Now move on.
I need to know now. You are the good. You still have one more part. The second part. Yes? The right-hand part.
You have to make the right hand part. You have to include us to us. No, this one the final answer. Yes, now. Because there is something. left hand side. How to get the derivative of the right hand side? Okay, for the right hand side, what's on the right hand side? Only to the left hand side. So the right hand side, for the right hand side, which evaluate what's it again? Previous power. What's on the right hand side?
Minus x. 1 plus x.
X squared. Right, yes. So can you do this now? I'm going to do the same way. Say that.
No.
I see.
Equal to UV minus.
My head have crashed out.
You can say that equal to e raised to power minus x, and this and the b equal to 1 plus x squared. So if you integrate this, it's going to give you x cubed over b.
Yes, so just keep it.
Okay.
Is that
Shorten our journey to go that way. U equal to 1 plus x squared, and the b equal to e raised to power minus x dx. So we're going to have our altogether the u dx will be equal to 2x, and then our b will be equal to minus e raised to power minus x. Is that clear? Is it clear? Yes. Then you can say that therefore integral of e raised to power minus x into 1 plus x squared x equal to, what will this be now? UV. That's 1 plus x squared multiplied by b. Our b is minus e raised to power minus x minus integral of b du. That will be minus e raised to power minus x. The u will be equal to 2x dx. This will be 2x dx. Right. So there's still a problem there, but the problem is going to be simpler. Okay, because we are working on differentiating this again, so this will become a constant altogether. So it is solving for that way. So this can go just this. Is e raised to power minus x into 1 plus x squared. Then you're going to have this to be plus 2 integral of x e raised to power minus x dx. So we can deal with this now. Are we together?
Don't clean, no?
So again, we can say that for that second part, can say next.
I got one cheese bag.
As for integral of x e raised to power minus x dx, we say that let's do equal to x and equal to e raised to power minus x. Yes, pay attention, please pay attention. Then we will have that u dx will be equal to 1, and in this case, v will be equal to, as usual, e raised to power minus e raised to power minus x. And so we can say that therefore integral of x e raised to power minus x dx equal to uv. That's going to be x multiplied by minus e raised to power minus x minus integral of v. That will be minus e raised to power minus x multiplied by u plus 1 multiplied by x. Is it clear?
Yes, sir.
So this is going to be minus x e raised to power minus x. This will now be plus integral of e raised to power minus x x. This is quite easy, Abby.
Yes, sir.
This is going to be minus x e raised to power minus x and minus e raised to power minus x. So you can move all of this to that. That's going to give us. Therefore, our integral of e raised to power minus x 1 plus x squared into x will be equal to e raised to power minus x into 1 plus x squared plus into this is minus x e raised to the power minus x minus e raised to the power minus x. That's going to give us e raised to the power minus x into 1 plus x squared minus 2x e raised to the power minus x minus e raised to the power minus x. That's that. So we can now put our result together. So this is going to be an implicit function. Okay. It's going to be an implicit function at the end of the day. Oh yeah. Like that, so that we'll move on. So we can move on. Yeah, I'm still moving. So permanent size. Yeah, we include it when we're putting together all the just solve the illustrations. You get not written our final answer.
I don't know. Like, this one is part of it.
Yeah, because you will show the video. That's his blessing.
That will not slow. No. Minus.
Max. When we stopped here, we needed to get this derivative. So that was what we did here. To arrive at this. Then here we are putting together the results. I'm putting this in place of this. So when you have to multiply by this expression,
That might like
oh, minus.
No, that's okay.
Minus 20 here. What we did is to find out this integral, then we substituted it. So let's write our final answer now. So what do we have on the left hand side? Let me write it down from so we have pay attention now, pay attention. We have this b raised to minus y over 2 into sin y minus plus y, right? Can you remember this? Then this will now be equal to left hand side, which is minus e raised to minus x into 1 plus x squared minus 2x e raised to minus x minus 2 e raised to minus x. That's some constants. Do you understand that? You get it? So that will be your constant of integration.
Give me a
You can leave it this way. You can And also factorize 2 to our minus x. You can see this equals to 2 to our minus y over 2 and y minus plus y. Minus x. 1 plus x squared minus but you understand what you get that? Yes. Alright, so plus so that's your well, so the answer is an implicit function.
How do you know that? Yeah, I don't know.
I've tried that.
Don't grab the answer and implicit it. Go meet the examiner and say, this thing is too simple. That's the only question. And you know for some man, you could just form your own. You said video, and then don't ask one way you reach. Yes, no matter. It's a long class like you, don't get. Hey, the one part. You know how this guy is.
I swear.
Let's form your own question, right? Following up, the lecturer might just see you and just think I'm sorry. Homogeneous equation. So you can have a differential equation that is homogeneous. Listen now, listen. I told you earlier that, listen, please listen. Please pay attention.
My book finish.
I told you something earlier that you should not mix up the homogeneity we discussed here with that of yesterday. Can you remember that? So a differential equation can be homogeneous in that respect. That you have a linear equation and b of x is 0. Can you remember that? Okay. And like we discussed yesterday, where we talked about homogeneous functions. You can have a differential equation that can be separated out such that what you have at the end of the day is going to be an homogeneous function. So that's what we want to consider now. So look at it this way. So look at it this way, that you can have a differential equation. The first order differential equation generally will be in this form. The y dx equal to some function that depends on x and y. Are we together? Look at this please. So if it happens that, listen now, if it happens that this function here, if it is homogeneous, according to our definition of yesterday, are we together? If it happens that this function here is homogeneous, then we say that this differential equation is homogeneous. Is that clear? Is that clear? In this respect. So it's a different concept entirely from what we discussed before. Alright, so when you have that, you can actually solve the differential equation using some method. And the method requires us to actually make a substitution. So we substitute y equals to bx. So in this case, b will be some function of x. Okay, I'm multiplying it with x. So that at the end of the day, we're going to make substitution for y prime also. Y prime is y dx. Okay? And that will help us simplify the equation such that it will now reduce it to a separable equation. And as before, we will solve it using the method of separable equation. So let's deal with one of them before we leave. So look at the first one. So you can see the, listen now, look at this. Look at the number 6. you asked to determine if the following D's are homogeneous. So what are you looking at? The function on the right hand side. Is that clear? By the time you write the y dx or y prime as the subject, what you have on the other side is it going to be a homogeneous function. If it's a homogeneous function, then that differential equation will be homogeneous in this context. Is that clear? Okay, so look at it now. What you have on the right side for Roman figure 1, is it homogeneous? Is it homogeneous? And you've forgotten what we did just yesterday. Look at the question, look at the question. What we have on the right hand side for number 6 Roman figure 1, is it homogeneous?
Yeah.
Yes.
Not homogeneous.
Why is it not homogeneous?
Because when there's x and x without y. K will not cancel.
What are you saying now? If you put k will cancel out now. I mean, you get k in the numerator and another k in the denominator. Abi now? So at the end of the day, it's going to be k raised to the power of 0. Abi? That means it is homogeneous of order 0. Can you remember that? Can you remember what we discussed yesterday? So that's an homogeneous equation. Look at the second one. Is it homogeneous? The second one. Is it homogeneous? No. You're going to have k squared, Abi, and over k. So look at the third one.
Yes.
Is it homogeneous? Look at the numerator. What are you going to get? K squared, Abi. Inside e raised to power x, that will cancel out. Inside sign, it will cancel out. The denominator will give you k squared also, which will cancel out as well. So that is what? Homogeneous. Does it make sense? Okay. Roman figure 4. Is it homogeneous? Yes. They will give us k cube, k cube. It will cancel out. Roman figure 5. Is it homogeneous? So now it is not separated out, but you can consider each of them. Do you get that? So the left hand side will also give you, look at the left hand side. We're going to have k cube in one and k square in the other. So that cannot be homogeneous. Do you understand me? Alright, so let's leave that aside. So they now ask us to solve the differential equations, the homogeneous differential equations. You can see that they have been repeated here. Number 6 Roman figure 1 is the same thing as number 7 Roman figure 1. Did you notice that? Because it's a homogeneous differential equation. So let's quickly solve this, then you go home and solve the others. Calm down. This thing is still plenty. Let's finish this. Then you do the others at home. Okay? So that you try the others at home. Okay? So let's quickly do it.
I swear, guys.
So we have y x equal to y plus x 1 over x. Listen now, listen. So we know that, please pay attention now. Listen please, listen. Are we together? So we know that this is homogeneous, Abi. So we can divide through by x or the highest power you have there. That means the highest power term you have in the expression. The highest power you have in the expression is 1. Do you understand what I just said? So if I divide through by x, this is going to give me something like y over x plus 1. Is that clear? Okay, so we can now say that let y equal to vx. Does that make sense? So if y is equal to vx, that means our y over x will be equal to v. Is it clear? Do you understand this? Okay, v is some function that depends on x as well. So if I differentiate this equation with respect to x, I'm going to have the y, the x is equal to, this will be product of two functions, Abi. So I'm going to differentiate this, keeping this constant. That will be x, the v, the x, plus differentiate this, keeping this constant, Abi. When I differentiate x, I get 1, Abi. That will be plus v. Is it making sense? Is that clear? Alright, so we can now make substitution here for the with the original equation. So in the original equation, we have this to be our dy dx. So we are going to use this instead of dy dx. Is that clear? Then we are going to use this instead of y over x. So substituting this and this. So let's say this is our equation 1, this is our equation 2, and this is our equation 3. So we're now looking at substituting equations and 3 in 1. What I'm going to get now, so instead of the y dx on this side, we get this y x. Instead of the y dx on this side, we're going to have x dv dx plus b, then equal to b plus 1. Is that clear? So b without b, I mean. So at the end of the day, you have a variable separable equation. Do you understand that? No. So this is going to give us, this calm down. This is going to give us, this is going to give us the b equal to 1 over x dx. Does that make sense? When I separate the variables, then we can now integrate and integrate. So what would that give us? B is equal to x plus some constant. Does it make sense? So we can now substitute back to get our y. You know y is what we need to get to solve the differential equation. Does it make sense? So at the end of the day, we're going to have y equal to b. Our b is x plus c multiplied by x. So our answer will be y equal to x into x plus c. That will be the solution of our differential equation. Does it make sense? So you make this substitution. Once you make the substitution, you reduce the equation to a separable equation. Then you separate the variables and integrate as we did for separable equations. Calm down and write. So if you have class, there's no need to rush. Understand this before you leave. So that tomorrow we are going to number 8. No, we are not doing this in the night. So in the morning we do differential equations. We continue with our normal outline for the evening.
Guys,
Make sure you understand this before you leave.
I don't want. Is it, I thought you said it was not writing again. Mark your phone.